Let's go to square roots. Our lesson for today is specifically square roots, but you cannot find the square root if you don't know what a perfect square number is or how to determine a perfect square number. What is a square root? So the symbol, this one, square root, that is the symbol for square root, this one. The symbol, that one, square root, means square root or power half. Square root or power half. So we are saying the square root of n is a number which when squared yields n. The square root of n is a number which when squared yields n. So when you are asked to find the square root of n, the square root of n is equals to n to the power what? Half. For example, the square root of 9 is equals to 3, meaning we want to find that number whereby when we square it, when we raise it to the power 2, it's going to give us a 9, which is 3. Let's look at an example. We have that example. Find the following. Find the following. Find the square root of 144. Find the square root of 144. Now, since we know that this symbol, square root, means power half, what we are going to do, we are going to remove this square root symbol by raising 144 to the power half. We are going to raise 144 to the power half. Now, when we put 144 to the power half, we have to determine whether 144 is a perfect square number. Let's do that. So we have to find the square of 144. When you use either the tree method or the table method, you find that the products of 144, the prime numbers, will be 2 and 2 and 3 times 2 and 2 and 3. So if you group them like that, you find that you are going to get 12 times 12, giving us 144. So 12 squared is equals to 144. If 12 squared is equals to 144, it means where there's 144 here, substitute or replace that 12 squared. That's what we are going to do. So where there's 144, we'll replace 12 squared. When you do that, you find that you are going to have two powers. We have a power 2 and a power half. We have this power 2 and the power half. When you have two powers, it is known as the index of an index or the power of a power. To get rid of those brackets, you are supposed to multiply those powers. That's what we are going to do. So we have 12 to the power 2 times half. We have 12 to the power 2 times half. So from here, we have a common factor, which is 2. We'll divide 2 into 2 to give us a 1. 12 raised to the power 1 is equals to 12. So meaning 12 is the number which is supposed to be raised to the power 2 or squared to give us what? 144. So when we square 12, what we are going to get is 144. The square root of 144 is what? Is 12. Let's go to the next example. We have 625. So they are saying find the square root of 625. Now we know by now that this symbol square root means what? Means power half. So we are going to replace that symbol by putting a power half. Now, when you look at that 625, we don't know whether it is a perfect square number or not. So what we are going to do, we are going to find the square of 625. What are we going to use? We'll use the tree method. From here, we cannot use 2 and we cannot use 3 as our prime numbers to divide into 625 because they are going to leave the remainder. So we'll go to the next prime number, which is 5. 5 into 625 will give us 125. Then we continue. 5 into 125 is 25. Then 5 into 25 is 5. We'll express as a product of its prime factors by multiplying 5 times 5 times 5 times 5, and then we'll group them. When we group them, we'll find that we are going to get 25 times 25, giving us 625. So 25 squared is equals to 625. 25 squared is equals to 625. So where there's 625, we'll substitute 25 squared. Let's do that. So where there's 625, we'll replace a 25 squared, or 25 to the power 2. Now we have 2 powers here, 2 and power half. Using the index of an index, what are we supposed to do? Multiply the powers. So we are going to multiply 2 times half. We are going to multiply 2 times half. We have a common factor here, which is 2. So say 2 into 2 will give us a 1. 25 to the power 1 is equals to what? To 25. I hope everyone is following. Let's go to the next example. We have square roots of fractions and decimal numbers. So it's not always that they are going to ask you to find square roots of whole numbers. Sometimes they can ask you to find the square root of a fraction or square root of a decimal number. Let's look at an example. We have that example which is saying evaluate the following. We have the square root of 25 over 49, or the square root of 25 divided by 49. Now this number on top is known as the numerator, and this number at the bottom is known as the denominator. So when you are asked to find the square root of a fraction, this is a common fraction because the numerator is smaller than the denominator. Find the square root of the numerator on its own and the square root of the denominator on its own. So you find the square root of 25 on its own and the square root of 49 on its own. Now, when you look at 25 and 49, you can see that these two are perfect square numbers. There's a number which we can multiply by itself twice to give us 25, which is 5, and 7 squared will give us 49. So our answer will be 5 over 7. As simple as that. Let's go to the next example.